Today we're going to be discussing percent yield in a reaction. So let's suppose we start off with 18 grams of carbon and we make 20 grams of methane. So we only make 20 in a real life experiment. So this is what we're going to call the experimental. Like we actually did the lab and this is what we got. But the question is, what is our percent yield? So what we need to figure out first is, well, what were we supposed to make? That would be the theoretical. And every time you want to find something that's theoretical, you're going to use the bridge or proportions or conversion factors. So we're going to balance the equation. So there's going to be a 1 and a 2 and a 1. And since this is in grams, we have to use the big bridge. So we're going to write the molar mass of each of these things. Remember that you're only adding up this. You're not adding up the coefficient with it. So that's a 2.0. This is a 12.0. And this is going to be a 16.0 as well. Okay, so now we're going to use the big bridge. So remember what we do. We do 18 divided by 1 divided by 12 times 16 times 1. And we're going to get an answer of 24. So we're supposed to make 24 grams of methane. That's the theoretical. That's if everything goes perfectly, that's what we're supposed to make. But we only made 20. So the percent yield is going to be 20 grams of what we actually made divided by 24 grams is what we were supposed to make times 100, and that's going to give us an 83.3% yield. You're used to this kind of calculation just from class. If you want to know what you got on a test or a quiz, let's suppose the quiz was worth 24. Theoretically, you were supposed to get 24 out of 24. But actually, you only got 20. So 20 out of 24, you'd have an 83.3%. So remember, it's going to be always the experimental. This is the experimental or the actual. Like, what did you actually get? And then the denominator is always going to be the theoretical. Okay, so let's move on to the next problem. Suppose that you have 49.7 grams of Cl2 and it makes 42.1 grams of the CCl4. So first step, balance. 1, 2, 1. And if you want, you could pause the video and try this on your own and then check your answers. I'll explain it now. So you have to do grams, so it's going to be big bridge again. So that's going to be 154. When you do your big bridge, 49.7 divided by 2 divided by 71 times 154 times 1, you're going to get 53.9. So that's what you are supposed to make. Again, that's the theoretical. However, in the lab, you only made 42.1. So since you only made 42.1, that's going to be your experimental. So now you take your experimental, 42.1, divided by theoretical, 53.9. I'm sorry, I wrote that wrong before. My mistake. Let's see if I can erase that. Sometimes it doesn't let me do that. It's not going to let me do that, so I'll just write over it. It's 53.9. 53.9, then you're going to do times 100. And that's going to give you a 78.1% yield. Now what happens if the problem is set up a little differently, such as in part B? I'm telling you the percent yield, and I'm telling you again the 60 is what you started with. So again, we're going to do big bridge. We're going to do 60 divided by 1 divided by 12 times 154 times 1. We find out that we're really supposed to make 770 grams of the product, so that's my theoretical. Now remember, in this case I'm telling you the percent yield, so what you need to do is work a little backwards here. I'll give you two methods. One is if you just realize that 70% is like 0.7, and then you multiply that by the theoretical, like you take 70% of 770. That's going to give you what you were supposed to get, which is your 539 grams of CCl4, and that's again going to be your experimental. That's the shorter way to do it. If that's a little confusing to you and you just really like to use the original formula, then you can go back to the original formula and say, okay, percent yield is experimental over theoretical, so times 100. So there's my percent. I don't know what my experimental is, right? But I do know what my theoretical is, which is 770. And then I'm going to have to go times 100 to get my answer. And then this will still come out to be 539 grams as your answer as well.